Let's have a look at question 1 of the November 2012 P2 Higher Physics paper. So, electrical resistance. Some students investigate the electrical resistance of different components using this circuit. And you can see there's a power supply, variable resistor, a test component, and then two other components called P and Q. It says which row of the table is correct for both meters P and Q. Well, the only meters we've come across are voltmeters and ammeters, so it's got to be one of the two, and the table clearly shows that. But which one is which? Well, if we remember back to what we've done in lessons, we should remember that current is a flow of electrical charge, and so you need to measure that at a single point. And so an ammeter has to go in series in a circuit, and we can clearly see that component P is in series. So P must be an ammeter, which means the correct answer is either A or B. Component Q, well, that's measuring between 2 points. So there, it could measure the difference, and that's exactly what it's measuring. It's measuring the difference in electrical potential, which we call the potential difference, or simply the voltage. So that makes Q a voltmeter. So the correct answer is B. But essentially, ammeters go in series, and voltmeters go in parallel. Okay, let's scroll down the page a little bit then. So it now says one of the components being investigated is a 12 ohm resistor. When it is in the circuit, the ammeter reading is 0.5 amps. Calculate the voltmeter reading. Well, we're going to need an equation for this, so let's go and have a look at what we're given at the start of this paper. So here we are, then we have the formula sheet here, and we can see the potential difference equals the current times resistance, or V equals I times R. So let's remember that then, V equals I times R, and go down to the question. So the first thing I'm going to do here is I'm going to write V equals I times R. I've been asked for the voltmeter reading. The current is 0.5. That's the I. The resistance is 12, that's the R, so it's 0.5 times 12, and if I wrote that down I would get 1 mark, and then the correct answer is a half of 12, which is 6, and that gets me the second mark. It then goes on to say that the students reduce the resistance of the variable resistor. State what happens to the readings on each of the meters P and Q. Well, a variable resistor, the resistor part means it makes the electrical current more difficult for it to flow. And so if we reduce that electrical current, then the current is going to go up. So the resistance, the value of meter P, and P was the ammeter, is going to increase. Meter Q is a voltmeter, and this is a bit more tricky to understand, but essentially we have whatever supply voltage, half of it is across here, and well, I say half, a proportion across here and a proportion across there. And if we add the voltage here with the voltage there, then they would equal the power supply voltage. If we're going to reduce this resistance, we're going to have less voltage dropped across the first resistor and more voltage dropped across this second component here, and so the voltage across Q is going to increase as well. Okay, it then says the students then reduce the voltage of the power supply. State what happens to the current in the circuit. Well, we talk about voltage as being the push that makes the current flow. And clearly, if we reduce the push that makes the current flow, we're going to get less current. So the current reduces for part 4 there. Okay, and finally then for this question, we've got 3 component graphs, L, M, and N, and 3 component symbols. So the first thing we need to make sure we're clear of is that that's a bulb, that's a resistor, and that is a diode. Now we need to know that the graph shape for a resistor is a dead straight line. So that must be N. So that's the graph of a resistor. We then need to know that for a bulb, because a bulb is a resistor that gets hotter, we get an S-shaped graph, which is this one here, which is L. And then finally, we need to know that a diode does not allow current to pass through in one direction, so the negative direction if you like, but does allow current to pass through in the positive direction when we get above a certain voltage, and that's going to make that one M. So going down the list from top to bottom, the filament bulb is L, the resistor is graph N, the diode is graph M. And that completes question 1.